Hi everyone, in this video we'll go through multiple angles and submultiple angle derivations from trigonometry. What are multiple angles? If A is any angle, then 2 times of A, 3 times of A, 4 times of A, 5 times of A and so on, they become multiple angles. What is the formulas for multiple angles? Right? In the earlier video we saw formulas for A plus B, sin A plus B, sin A minus B, cos A plus B, cos A minus B. Now in this video, we will use the same compound angle concept and find out what is sin 2A, cos 2A, tan 2A and so on. Now remember one thing, you don't have to memorize all of the formulas. If you can remember compound angle formulae, right? If you can remember compound angle formulae, then you can derive the multiple angle and submultiple angle formulas. Now these were the compound angle formulae. Sin A plus B, cos A plus B, tan A plus B, sin A minus B, cos A minus B, tan A minus B. Now we will have to remember these formulas, and it is easy. It's not that complicated. We can always remember these formulas, especially the cos formulas and tan formulas. Now using these formulas, we'll derive multiple angle formulas. That is sin 2A, cos 2A, tan 2A, sin 3A, cos 3A, tan 3A. We can derive all of this. There is no need to memorize. But if you can memorize these formulas, right? Out of these formulas, we can obtain these formulas. See, it's always good to memorize. But in case, right, there are times when we get confused or we forget. In such cases, we can always use the method of derivation, right, to remember these formulas. Let's see how to derive multiple angle formula. It is very simple. Sin 2A. Now what is sin 2A? We can write sin 2A as A plus A, right? Sin 2A as A plus A. Now we can use sin A plus B formula, right? What was sin A plus B? Sin A plus B is sin A cos B plus cos A sin B. Using this, we will derive sin 2A. Now what we'll have to do? Instead of B, right? Instead of B, we'll use A because we want 2A, right? So instead of B, we'll put A. So put B is equal to A. So we'll get sin A plus A. Now we'll substitute. So we'll have sin A into cos A plus cos A into sin A. We are substituting A for B. Now we'll get sin A plus cos A plus sin A. It's the same thing, right? So it is 2 sin A into cos A. This is one term, this is one term. So it is 2 sin A cos A, right? And this sin A plus A is nothing but sin 2A. So this is the formula. You notice this? Sin 2A is nothing but 2 sin A into cos A. Very simple. Just by looking at this particular formula, you can quickly figure out 2A formula, right? What will be 2A? Instead of B, put A. So by looking at itself, you'll know it's going to be 2 sin A cos A. Similarly, what is cos 2A? Same thing. Cos 2A is A plus A. So we'll use cos A plus B. What is cos A plus B? Cos A plus B is cos A into cos B minus sin A into sin B. So we have cos on one side and sin on one side and opposite side. Here we have plus and here we'll have minus. Right? Now what we will do here, we'll substitute B as A. Why? Because we need cos A plus A. We need cos A plus A. So we'll have to substitute B with A. So what will happen to this formula? It's going to be cos A into cos A. Instead of B, we are putting A. Similarly here, sin A into sin A. Now what is cos A into cos A? Cos square A, correct? Cos A into cos A is cos square A. Sin A into sin A is sin square A. Now we have one trigonometric formula where cos square A plus sin square A is equal to 1. We'll have to remember this. This is again important formula. This is used in trigonometry very often. Cos square A plus sin square A is equal to 1. Now what does this mean? I can say cos square A is 1 minus sin square A. Basically, I am finding cos square A and shifting sin square A here to the other side. So it will become 1 minus sin square A. Similarly, sin square A. Sin square A, I will shift cos square A now. Sin square A will be 1 minus cos square A. 1 minus cos square A. Right? When I shift cos square A to the other side, I'll get 1 minus cos square A. And that is nothing but sin square A. So now, using this particular formula, I'll get two other derivations. Now, I can substitute this. I can substitute, instead of cos square A here, I can substitute this. Right? And then instead of sin square A, I can substitute this. So, first, we will substitute cos square A. So, we have cos 2A. This is second formula. Cos 2A is, instead of cos square A, let me write this. Instead of cos square A, I'll put 1 minus sin square A. And then I'll copy sin square A as it is. So what is this? This is nothing minus sin square A minus sin square A. So it is minus 2 sin square A. Correct? This is 1 minus 2 sin square A. This is cos 2A. This is second formula. So this was first formula. This is second formula. Now we'll get third formula. For third formula, what we will do is we'll substitute sin square A. Right? What is sin square A? Sin square is 1 minus cos square A, right? Now, instead of sin square A, I'll put 1 minus cos square A, right? I'll substitute this one in this particular expression. And I'll just leave cos square A as it is. So, I will get cos square A minus 1 minus and minus plus cos square A. So, what is this? This is 2 cos square A minus 1. So, this is third formula. Now, you see, for cos 2A, we have, this is one formula, this is one formula, and this is one formula. We have got sin 2A, we have derived this, we have derived all of these three. Now we will go to tan 2A. Let's derive tan 2A also. Again, for tan 2A, we'll write it as tan A plus A, right? And we will have to use tan A plus B formula. What is tan A plus B? Tan A plus B is tan A plus tan B by 1 minus tan A into tan B. Right? Anytime you get confused with the signs, right? This sign and this sign should be same, and here it should be opposite sign. Right? Now we will substitute. So instead of B, I'll put A because I need A plus A. I need A plus A, right? So instead of B, I'll put A here in this formula. So I'll get tan A plus tan A equal to 1 minus tan A into tan A. So what is this? 2 tan A by 1 minus tan A into tan A is tan square A. Simple. So this is tan 2A. So we've got tan 2A as 2 tan A by 1 minus tan square A. Simple, right? So we have derived sin 2A, cos 2A and tan 2A, right? Now, do you think we really have to memorize all this? You can try to memorize, right? There's no harm. But in case you forget, right? In case you get confused, then go through the derivation. Derivation will not take more than a minute, right? Right? If you have understood the concept, deriving these formulas will not take more than a minute or two. And with continuous practice, right, you will automatically remember these formulas. Once or twice you try to derive it, then you will automatically remember the formula, right? And even if you don't remember, you can always go with derivation. Trigonometry is not that very tough, right? There is always a notion that trigonometry is tough because of too many formulas, right? I agree. But wherever possible, we can always try to derive the formulas. Similarly, we can have sin 3a, cos 3a, tan 3a. You can use the same method of derivation. Can you guess how I'll find cos 3a? How would I find cos 3a? Any guesses? Right? What will I do? I'll write as cos 2a plus a. Right? Now I'll use cos a plus b formula. Only difference is instead of a, I have 2a. Instead of b, I have a. So I substitute everywhere. I'll put 2a here. I'll put a here. Right? Then you get cos 2a. Right? Here. What is cos 2a? We'll use this cos 2a formula. Right? We'll use this cos 2a formula. Substitute here. Substitute here. And then we'll also use sin 2a formula. We already obtained sin 2a, is it not here? 2 sin a cos a. We'll substitute here. So you can substitute this way and finally get these particular expressions or formulas. Now we'll go through submultiple angle. What is submultiple angle? Nothing but in fractions, right? You have a by 2, a by 3, a by 4. Assuming that a is some angle, right? Assuming that a is some angle. A by 2, a by 3, a by 4, a by 5. Anything like a fraction becomes a submultiple angle. Here is a list of submultiple angle formulae. Sin a in terms of a by 2. This a by 2 is a submultiple angle. You can also have sin a in terms of tan. The entire formula will have tan, right? Then you can have cos a. There are 4 formulas, right? Because we can use cos square a plus sin square a is equal to 1. So you can have cos square a is equal to 1 minus sin square a, and sin square a is 1 minus cos square a. Because we have 3 derivations here, right? We can substitute cos square A with this and then sin square A with this. So you'll get three variations. You'll get three variations of formulae. And then we have one thing completely with tan representation. And then we have tan A, which is 2 tan A by 2 by 1 minus tan square A by 2. Let's go through derivation of each of this. There are two methods to arrive at submultiple angles, right? Method 1 and method 2. Method 1, I am using compound angle formulae, right? You remember, even for multiple angle, I used compound angle. What is compound angle? Compound angle is nothing but where you have two angles, a combination of two angles, right? Addition of two angles, subtraction of two angles, sin A plus B, cos A plus B, sin A minus B, cos A minus B. So these are compound angles. Now using the same compound angle formula, we can arrive at submultiple angle. And second method is you use multiple angle formula, right? This is multiple angle. We just now saw, right? We just now saw how to arrive at sin 2A. This is nothing but multiple angle. 2A, 3A. These are multiple angles. So using multiple angle formula, you can easily get submultiple angle. But I'll teach both the methods. Right? Again, easier method, let me tell you, easier method is this one. Using multiple angle, which is there in the textbook today. In the textbook, this particular method is used. But I will also explain this method. Only advantage with this method is you don't have to remember multiple angle formulae. That is, you don't have to remember sin 2A, cos 2A, tan 2A. You don't have to remember all these formulas. You can just use sin A plus B, A minus B, right? You can use these formulas and try to derive this. So in case you have forgotten these multiple angles, don't worry. Use this compound angle formulas and try to derive it, right? That's why I'm always telling, memorize the compound angle formula. Multiple and submultiple, you can automatically derive it, right? I'll go through this method 1. Sin A plus B is equal to sin A cos B, cos A sin B. Now what I will do is, instead of B, I will put A by 2. Instead of B, I'll put A by 2. Instead of A, I'll put A by 2. Basically, I need to get a submultiple angle, right? What is submultiple angle? It's a fraction like A by 2, A by 3, A by 4. So I'm putting A by 2 here now, right? If I put A by 2 here, what will happen? Sin A by 2 plus A by 2. Now I'll substitute. Sin A by 2. Instead of B, I'll put A by 2. A is A by 2. B is A by 2. After substituting, so both these terms are same, right? Both these terms are same. So you'll get 2 times sin A by 2 into cos A by 2. This is once and this is once. So you have 2 times sin A by 2 cos A by 2. Simple, right? We got sin A now. A by 2 plus A by 2 is A, right? A by 2 plus A by 2 is A. So sin A is 2 sin A by 2 into cos A by 2. Now we'll go to the alternate method, which is given in the textbook, using multiple angle formula. That is using sin 2A. Sin 2A is 2 sin A into cos A. Correct? Sin 2A is 2 sin A into cos A. We just saw that here. Sin 2A is 2 sin A cos A. Right? Now using this formula of multiple angles, we'll derive the same formula. Sin 2A is equal to 2 sin A cos A. Now here you'll put A is equal to A by 2. A is equal to A by 2. Right? Because you want it in the form of submultiple angle. That is, you want it in the form of A by 2. So instead of A, I'm putting A by 2. So what I will get? 2 sin A by 2 into cos A by 2. And here it is 2A. So 2 into A by 2. 2 and 2 will get cancelled. I'll be left with sin A. Sin A is 2 sin A by 2 into cos A by 2. Same thing. You see that? Same thing. I've got the same answer, but I've used different formulas. Right? I would call this compound angle formula as a base formula. Right? Because ultimately, this multiple angle formula, that is sin 2A, cos 2A, is derived from this compound angle itself. Right? So therefore, this can be called as base formula. I can use that and derive. Advantages, I don't have to by heart. Right? Don't have to at least worry that if I don't remember the formulas, I cannot solve the sum. You can attempt to solve the sum by deriving it in this manner, provided you remember the compound angle formulas. We can also express sin A in terms of tan, right? Here we have sin A in terms of sin and cos. Now we can also express the sin A, that is get sin A in terms of tan. So basically this becomes another formula for sin A. One formula is this one, right? And this is second formula for sin A. So what do we have to do for this? I'll start with multiple angle formula. So what is sin A? We just got sin A, right? This is sin A. Now we'll use the same formula 1 and get represented in terms of tan, right? What I will do is, now in this entire expression you need tan, right? You have sine, you have cos. How do you get tan? What is tan formula? Tan A is sine by cos, correct? Sine A by cos A is tan. Here I have sine. What I can do to make it tan? I can divide by cos. If I divide by cos, I will get sine A by cos A, which is tan A. But if I divide, I need to multiply also. If I have to balance this entire equation, then I have to perform an operation in the numerator and denominator. Same operation. Here I have to multiply with cos A by 2. If I have to divide by cos A by 2. Right? Now I am doing that. So we'll multiply the numerator and denominator by cos A by 2. 2 sin A by 2 by cos A by 2 becomes 2 tan A by 2. And then we have cos A into cos A by 2. Cos A by 2 into cos A by 2. What is that? It's cos square A by 2. Right? Cos into cos is cos square A by 2. Now, if I have to get everything, the entire formula should be in the tan representation. We should have tan in the formula. We cannot have cos. We have to get rid of this cos value. How do we do that? Right? We'll have to do step by step. What is cos? We can write cos A by 2 as 1 by secant A. Cos A is 1 by secant A, correct? So therefore, cos square A is 1 by secant square A, correct? So instead of cos square A by 2, I can write 1 by secant square A by 2. Now one step is over. How do I get rid of secant square? There is another formula. Secant square A is 1 plus tan square A. Secant square A is 1 plus tan square A. So you'll have to memorize this. Right? You can derive this formula also. Right? There is a derivation for this, but it is too much of derivation. It's better to memorize. I can explain how to derive this. But for now, let's take this particular formula as is. Right? In case you want derivation for this, do let me know. I can have a separate video for this. In case you want to understand how to derive this. Simple 2-3 steps. That's it. Right? Now, 1 by secant square A by 2 would be, substitute secant square A by 2 with 1 plus tan square. So we have 2 tan A by 2 by 1 plus tan square A by 2. So we've got the formula. So we got the formula for sine A. Two formulas are there for sine A. One is in terms of sine and cos. One is completely in terms of tan. Now we'll go to cos A. What is cos A? Right? Again, let's go to method 1. Method 1 is using compound angle formula. What is compound angle formula for cos A plus B? Cos A plus B is cos A cos B minus sin A sin B. Now I will substitute A by 2 for B. I'll put B as A by 2 and A as A by 2. So put A by 2 plus A by 2, because A by 2 plus A by 2 is 2 into A by 2. 2 and 2 will get cancelled. We'll get cos A. Right? Now similarly here, instead of A I'm putting A by 2, instead of B I'm putting A by 2. So what will happen? You have the same terms. Here. Cos into cos is cos square A by 2. Sin into sin is sin square A by 2. So cos A is cos square A by 2 minus sin square A by 2. So this is method 1. Now let's go to second method. Second method is using multiple angle. So first method was using compound angle formula. Second method is using multiple angle formula. What is multiple angle? That is cos 2A. We'll have to use cos 2A because we want to find cos A formulas. Right? Cos 2A is cos square A minus sin square A. Right? This is the formula for cos 2A. Now you put A is equal to A by 2. Instead of A, I put A by 2. Right? So instead of A by 2, instead of A by 2. Simple. I got this particular formula. Same as this. Right? Same as this. Both are same. Right? Using both the methods, we got the same formula. Now, there is an important formula, right? Like we discussed earlier. Cos square A plus sin square A is 1. What you can do? Cos square A plus sin square A is 1. Means cos square A is equal to 1 minus sin square A. Correct? Cos square A, you shift this sin square A to the other side. It will become 1 minus sin square A. This is cos square A. Now I'll substitute cos square A here. Right? I'll substitute cos square. Instead of putting cos square A by 2, I'll put 1 minus sine square a by 2. 1 minus sine square a by 2. If I put 1 minus sine square a by 2 here, if I simplify, I'll get 1 minus 2 sine square a by 2. 1 minus 2 sine square a by 2. Next, what I will do, this is second. So this is second formula. The third formula is, instead of sine square, I can put, instead of sine square, I can put 1 minus cos square a. That is, I shift cos square a to the other side. I'll get sine square a. Sine square a is 1 minus cos square a. So I'll put sine square a is equal to 1 minus cos square a. I'll substitute this here. Right? Instead of sine square a, I'll put 1 minus cos square a. That is, copy this cos square a by 2 minus, instead of sine square a by 2, I put 1 minus cos square a by 2. Now I'll simplify. Cos square a by 2 minus 1, minus into minus is plus, plus cos square a by 2. Cos square a by 2 plus cos square a by 2 is 2 cos square a by 2, and then we have minus 1. So we got the third formula. Now, fourth formula. You remember, for sine a, we got it in terms of tan. Now, we want to get cos a also in terms of tan. That is, entire formula should be in terms of tan. So, we'll start with this first formula. What did we get here? This formula. Cos a is cos square a by 2 minus sine square a by 2. We'll use this formula. Since we need to get tan, simple. We need to get sine by cos. Only if we get sine by cos, we'll get tan. So what you do? Same thing. We'll multiply and divide by cos square a by 2. So what will happen now? I'll split this, right? I'll write it as cos square a by 2 by cos square a by 2 minus sine square a by 2 by cos square a by 2, right? This is a common denominator, right? This denominator is there for this one also. This denominator is there for this one also. So I'm splitting both these terms like this. And then I have multiplied with cos square a by 2. Now cos square a and cos square a will get cancelled. So it will become 1. Minus sine by cos is tan. So sine square by cos square a by 2 is tan square a by 2. Now I'm still left with cos square a by 2. I want to get rid of this. Why? Because I want entire formula in terms of tan. I have to get rid of this. To get rid of this, same formula will use. Cos a is 1 by secant a. Correct? Cos a is 1 by secant a. Which means cos square a is 1 by secant square a. So instead of cos square a by 2, I'll put 1 by secant square a by 2. Then we'll use this formula which we used earlier also. Right? We used this formula earlier also. Secant square a is 1 plus tan square a. So I'll put that. Instead of secant square, I'll put 1 plus tan square a by 2. That's it. That's the formula. So cos a is 1 minus tan square a by 2 by 1 plus tan square a by 2. Now we finished with sin a and cos a. Now we'll have to arrive with tan a. Right? Now again, two methods. Use multiple angle formula, use compound angle formula. Right? Both the methods you try to understand and use whichever is convenient. We'll use the multiple angle formula. Right? Multiple angle formula is, you'll have to remember tan 2a is 2 tan a by 1 minus tan square. You have to remember this. Since it is difficult to remember, I suggested to use this alternate method. Now, if you can remember this formula, then put this particular formula and put a is equal to a by 2. Substitute. Instead of a, I put a by 2. Right? That's it. You're done. Here 2 and 2 will get cancelled. So you'll get tan a is equal to 2 tan a by 2 by 1 minus tan square a by 2. Simple. Let's see the alternate method using compound angle formula. What is compound angle formula for tan a plus b? Tan a plus tan b by 1 minus tan a into tan b. Now here I'll have to substitute b as a by 2 and a as a by 2. When I substitute both, right, and substitute everywhere, here 2 and 2 will get cancelled. I'll get tan a, and this is going to be tan a by 2 plus tan a by 2, which is nothing but 2 tan a by 2. Tan a by 2 plus tan a by 2 is 2 tan a by 2 by 1 minus tan a by 2 into tan a by 2 is tan square. Tan square. Tan into tan is tan square a by 2. So we've got the same formula using both the methods. So here's the summary. Here's the list of submultiple angle formulae that we have derived today. With this, we have come to the end of this particular topic. If you have found this video useful, do share it and like it.